Now let's take a look at the effects of temperature and pH on the enzyme. Okay, you'll realize that the graphs for enzymes versus the graph for pH is drastically different, even though the shape is the same. Okay, so the shape for temperature, it has a wider shape to it, okay, a wider curve. Whereas if we were to take a look at the shape of the effect of pH, okay, pH has a narrower range to it. Okay, so let's study or analyze the effect of temperature first. Okay, so for temperatures, at very low temperature, there is very low kinetic energy of the particles. So which means to say that the particles are not able to vibrate as much as possible. And for that, we call it low frequency of effective collisions. Okay, take note, this phrase has to come together and you are not to change any of the components of the phrase. Okay, so of course, when heat is applied or when it is left out in room temperature, as compared to if you are taking it out from the fridge itself, what happens is that these particles, they gain energy. Okay, so when they gain energy, they will increase in their effective collisions. So when they collide together, imagine if we have a room, okay, and if people are going to move faster or run at a faster speed, the impact or the chances of people colliding will be much higher. Okay, so the same concept applies, whereby the possibility or the frequency of my enzymes and my substrate that is able to collide on a higher frequency will actually be higher. Okay, so right at the optimum temperature, for humans it will be 37 degrees Celsius, our normal body temperature. So right at the optimum temperature, I have got maximum frequency of effective collisions. So which means to say that my enzymes and my substrates, they are colliding at the maximum possible level in a correct orientation. Okay, so in order for my enzyme substrate complexes to form, not only does my collisions have to occur, my substrates have to be able to collide correctly into my enzymes in order for the substrate to fit into the active site of the enzyme. Okay, so that is why I have got a maximum kinetic energy and a maximum enzyme activity taking place for enzymes. Okay, so when excessive energy is being provided, what happens is that my enzymes are going to vibrate even more. Okay, so these vibrations at high levels will result in the loss of hydrogen bonds. Okay, so recall that proteins, they are what that is making these enzymes. So proteins, they have what we call hydrogen bonds between the oxygen and hydrogen molecules. Okay, so these are temporary bonds. They are not like covalent bonds that you do in chemistry. So these temporary bonds, they help to give the three-dimensional shape of proteins. Okay, so you can see here, protein is actually a very three-dimensional shape. And what holds this protein together are these little bonds in between each protein molecules. So these bonds, they are not the strongest bonds, but they are required to give the protein structure the shape that it deserves and it requires to perform the reaction. Okay, so when I have got excessive energy, excessive vibration of my enzyme, I will lose these hydrogen bonds, and that result in a denatured enzyme. Okay, so as you can see, once the enzyme has denatured, what happens is that my active site is lost. Okay, so once it is lost, my substrate can no longer bind to the active site, resulting in an irreversible change of structure for the enzyme itself. Okay, so note the difference. At low temperatures, there is no irreversible change. I just have to gain kinetic energy. However, at high temperatures, I can lose the structure of the enzyme, resulting in irreversible change.